You knew it would come and haunt you. Okay, yeah, this was completely quarantine.
You said there was like 7 views on the videos.
Yeah, I told you to watch it.
I'm still watching.
Thank you. All right, so the trig identities that you need to remember are the reciprocal ones, which you should probably, most of you remember. I'll write them down right now. Reciprocal identities. Your tan is equal to sine over cosine. And by the way, if you don't like theta, you can put an X. It's fine with me. Thank you. Your cotangent would be the flip of that, cosine over sine. Some other ones are cosecant, which is equal to 1 over sine, and secant, which is 1 over cosine. And I'm only going to write those, thank you, because if you remember from quarantine videos, we convert everything to sines and cosines. So you don't want to have tan when you can convert everything to a sine or a cosine. You don't want to have a secant when you can call it 1 over cosine. Okay, that's what we do with the trig identities. Those are the reciprocal ones. Then there was the Pythagorean ones. Okay, the Pythagorean identities. And they look like Pythagorean theorem, like you'll always have a 1 and a squared and another squared kind of thing going on. So here's what I mean. My favorite one is the promposal that no one stole. Sine squared, if you were a sine squared and I was a cosine squared, together we make 1. Okay, it was a good one. It was a good one. Why are you not? Now, by the way, all the manipulations within this are also part of it. Here's what I mean. I could solve this for cosine squared. If I said keep cosine squared on this side, wouldn't you subtract that over? So cosine squared is actually equal to 1 minus sine squared. That's another Pythagorean identity, but no one writes that down as a Pythagorean identity because it is already a manipulation of this. What could I say about sine squared? What is that one? What's that one equal to? 1 minus cosine squared. Good job. Okay. So these are, they're manipulations from this one. So you need to look for this. This could also occur. Same thing here, 1 plus tan squared theta equals secant squared theta. And it's manipulation. I could solve for tan. I could move over the 1. 1 plus cotangent squared theta equals cosecant squared theta. Those also are, these are all the Pythagoreans and their manipulations and their solving for tan squared. Okay, then we have double angle formula. We don't do half angle. We should, because that would really show me if you watched it. But the double angle formula for identities are the following. If you have sine of 2 theta or sine of 2x, what's called a double angle, okay? Not sine squared, sine of 2x. Not 2 sine x, sine of 2, sine of something. It'll actually have a 2 here in front. That is equivalent to 2 sine theta cosine theta. And then there was a cosine one, a double angle cosine. Actually, there was 3 of them. And you can use whichever 3 you want, okay? The one that's popular is this one, cosine squared theta minus sine squared theta, not to be confused with plus. If this was a plus, then it would equal 1. If it's a minus, then it equals cosine 2 theta, okay? Another one would be 1 minus 2 sine squared theta. And then even another one is 2 cosine squared theta minus 1, okay? These all 3 mean that. They're all the same for that one. All right, and then this has, I don't know why I wrote it down, so I'm wondering if we're going to use it in the future. I know it's not on this worksheet, but write this down. These are the addition, subtraction formulas for sine and cosine. It's not on this worksheet, but just write it down anyway. And it was this one. It was the sine of A plus or minus B. And that one is equivalent to sine A cosine B plus or minus cosine A sine B. And then there's a cosine one. There's actually a tan one too, but we don't have to worry about that. This one is cosine A cosine B. When it's cosine, it's cos. And then it's minus plus. So if this was a plus, this would be a minus. Sine. Okay. This is not on tonight's homework at all. I don't know why I have it in my notes. I must have put it there for something in the future, but just so you know, everything else is what you're going to want to focus on. Now, I'm going to be very kind to you. I'm going to do 2 of the problems from your homework tonight. And by the way, your homework, give me your homework real quick, Woody. Okay. On the front side, this side right here that says trig identities, you are just doing the evens. You're welcome. Just the even. Okay. On the back side, go to the middle section where it says prove, and you're just doing A, B, C, D, and E. Okay. Now, I'm going to be dead honest with you. They're hard. They're supposed to be.
Wait, which one?
They're going to stretch your brain. You need to practice them. You have to manipulate. Okay? So we're going to do, can I write on here for you? Thanks, Ben. You knew I'm here for you. I'm going to do the same thing I did in the other class. I'm going to do number 5, but it's not an even. I know. But then I'll do, oh, stop. And then I'll do number 12 because you all know that you don't do 12. Yeah, I don't do the lowest problem. It's against my religion. Okay.
Yeah.
All right. So I'm going to do 5 and 12 on here, and that's what I did in the other class, and then that's what you'll get for homework. All right. So keep your identities out on the side. You've got cosine over 1 minus sine minus cosine over 1 plus sine equals 2 tan x. So kind of keep the right side there. We're going to work on this side. You're looking at it and you're probably thinking, but everything's already cosines and sines. It is, but there's things you can do. It's a fraction minus another fraction. You want to make it one fraction then, okay? So we are going to do what we do with fractions. We find common denominators, which in this case, they both would be my common denominator. So my common denominator would be 1 minus sine x times 1 plus sine x. Now, what would be the new numerator? What would I have to multiply this cosine by? By the 1 plus sine x, right? Really, it's crisscross if you don't remember. Okay? So what's cosine times 1 plus sine x? We'll distribute it. What's cosine times 1? Cosine x. Plus, what's cosine times sine? Well, you write cosine sine. Cosine sine. What about this way? I'm going to put the negative right next to the cosine. You still do the same thing. You distribute. What's a negative cosine times 1? Negative cosine x. What's a negative cosine times a negative sine? Positive cosine sine. Positive cosine sine. Now, you might think, Lucetta, that looks terrible. I didn't. I've actually helped myself out right now because look what happens. What happens to the cosine x's? Bye-bye. If I have one cosine sine and another cosine sine, how many cosine sines do I have?
2.
And you put the 2 out in front. So you have 2 cosine sines. That whole top became 2 cosine sine. What do I do here on the bottom? Well, doesn't this look like they look like conjugates, right? They're the same thing except a plus and a minus in the middle. So what do you do with conjugates? You FOIL them, and what happens to the middles? They cancel out. You flip. So just do 1 times 1, 1, sine times sine. What's sine times sine? Sine squared. So 1 minus sine squared x, not sine x squared, sine squared x. Now let's look back at your little trig identity. Do we see anything?
No.
Oh, so this right here, this denominator, you can essentially cancel it out and replace it with cosine squared x, because that's what it's equivalent to. And now, if you're multiplying things on top and then you have one monomial looking thing on the bottom, what can cancel from top to bottom? So what would you have left? 2 sine x over 1 cosine x on the bottom. Would you agree? And what's sine over cosine, everybody?
Tan.
Wow.
Wait, if they already gave us that.
Well, of course they gave it to you. You're proving it.
You're making sure.
You're proving it. Okay? All right, number 12. I'll do number 12 for you, and then that will be you. This will be your homework tonight. It's a challenge, but it's fun. I love it. I do love it. Okay, so the tan, you can convert that to sine and cosine, excuse me, but I'm just actually going to work on this side, the right-hand side. I'm going to try to clean this up to the best of my knowledge. Sine 2x, do I have an identity for that? What is it? 2 sine x cosine x, okay? Over 1, just leave it 1, plus, do I have an identity for cosine 2x? I actually have 3. Which one do I choose? It doesn't matter. You should get the same answer no matter what. I'm going to choose the top one just because I always go with that one. So cosine 2x is equivalent to cosine squared x minus sine squared x. This right here, what I just squiggled, is what cosine 2x is. Does that make sense? I've just replaced this with that. Now, how did that help me out? I don't know, Miss. How does that help me out? Well, here's what you can do in math. You can rearrange these things. You are allowed to move them around. So I'm going to go like this. 1 minus sine squared x plus cosine squared x. Why am I doing that? Well, because this, my friends, is something on your little sheet there. It's cosine squared. So let's just cross that thing out and call it cosine squared. So if you have a cosine squared and another cosine squared on the bottom, how many cosine squared you got, kiddos? You have to talk to yourself like this, I'm telling you. Because if you're not, you're going to multiply them and it's going to be wrong. 1 cosine squared, another cosine squared makes 2 cosine squared x. The top still has a 2, a sine x, and a cosine x. Can you simplify that anymore? Goodbye 2's. Goodbye cosine, and you're left with 1 on the bottom. Oh, you're left with a sine over a cosine, which, my dear friends, is tan. Okay? Are these going to hurt your brain? They are. They are. Okay? But they're fun. And when you get it, you feel good about yourself.
No, they already gave us the answer.
They already gave you the answer, so you know it.
I